Hello, everyone. We'll wait for about 5 minutes till everyone joins and then we'll start the session. Hello everyone. I hope I'm audible to everyone. Anyone can anyone confirm?
Yes, ma'am.
Okay. So welcome all to the second TA session for drug delivery principles in engineering. I'll now share my screen and we'll discuss some previous year assignments for this week. I hope everybody can see my screen.
Yes, ma'am.
Okay. So in the second week, these were the topics that was covered. First, biomedical polymers, wherein different kind of uh, lactic acid polymers, PLA, PGA, polyesters, as well as the uh, polyanhydrides were discussed. And then polymer drug conjugates, how using different drug moieties in the drug or the polymer systems, you can conjugate and make a complex system for different applications. Diffusion of control system and controlled release reservoir systems. So we'll based on these topics, there were some previous year questions in the assignment and we'll discuss some of those. So this was the first question for a so not only this, the whatever was covered on the first week, it's also both first and second week combined. The questions will be both from first and second week. So this is the first question. For a given polymer, rank Tg glass transition temperature, Tm melting temperature, and Tc crystallization point from lowest to highest. And these are the options. I'll give you some time to go through the question and let me know what you think the answer is, and then we'll discuss. You have to rank the temperatures from lowest to highest. Anybody? Anyone would like to answer? Okay, so this will be the answer: Tg, Tc, and Tm. This second option. So if there is a polymer and you continue to heat it, continue increasing the temperature, then first you'll have a glass transition temperature at which the polymer undergoes from a hard glassy state to a more rubbery state, and then there is a crystallinity uh, crystallization temperature above which it loses its crystallinity. And then if you still go on further, you'll have Tm, or melting temperature, which is the temperature at which all the crystalline regions melt. So lowest will be Tg, and then Tc, and then Tm. Here is the next question. Which of the following statements is not a limitation of polymer drug conjugates? You have to select two statements. The options are: biomolecule or drug can lose activity during conjugation process. Purification of unreacted polymer biomolecules and any reaction products is necessary before in vivo application. Sterilization process now involves polymer stability. It can be viewed by regulatory authorities as a new drug entity. Polymer drug conjugates can improve bioavailability of many poorly soluble drugs. If not compatible, they can trigger inflammatory reactions. And the last option, the polymer drug conjugates can be made targeted for specific applications. Which of this do you think is not a limitation of the polymer drug conjugates? You have to select two statements. Anybody would like to answer?
Option 5 and 7.
Sorry, can you repeat?
Option 5 and 7.
Option 5 and 7. Okay. What about others? Anybody else would like to answer? Which of these is not a limitation of polymer drug conjugates? Till now we have one answer. Anybody else would like to volunteer?
Ma'am, option 3rd.
Option third, okay. And one more, you have to select two statements here.
Option third and fourth.
Okay. So we have two answers now. Anybody else? Okay, let's look into the answer. So option 5 and 7, uh, polymer drug conjugates can improve bioavailability of many poorly soluble drugs, and polymer drug conjugates can be made targeted for specific applications. These two will be the correct statements. Here the question is asking not a limitation. So basically advantages of polymer drug conjugates. So it can improve bioavailability, that is one advantage, and it can be made for specific applications. So polymer drug conjugates are basically you have a modified version. You conjugate the drug to the polymer, and then by water or enzyme there is the bond between the polymer and drug breaks, and that's how the small drug molecules gets released. And there are several methods of this conjugation, but we'll only discuss about the advantages and limitations. So if you look at the advantages, uh, it modifies the chemical properties to enhance the solubility, and it protects labile drugs from biochemical degradation, that is provides stability. Provides stability, increases half-life, reduces immunogenicity and toxicity, improves targeting, specificity and bioavailability, and drug conjugation via degradable bonds for controlled release. And it can be also made to release a stimuli responsive. So under specific conditions only it will release. So these are the advantages of drug conjugation to polymers, and limitations would be it can lose activity during conjugation process. So you need to be very careful to on what chemistry and reaction sites you are involving. Purification of unreacted polymer and biomolecules and any reaction product is necessary before in vivo application. Sterilization process now involves polymer stability and can be viewed by regulatory authorities as new drug entity, even though the drug molecule itself is well used and could take years and years along with high cost. So yeah, even though these are basically the limitations, the sterilization process now involves polymer stability as well as the can be viewed by regulatory authorities as a new drug entity. These would be the limitations, and the fifth and seventh options would be the advantages or not a limitation, which are the correct options. Okay, here is the next question. So we have a gold surface that was grafted with polymer, and the ends of this polymer are tagged with four pendant groups, namely A, B, C, and D. And the pendant groups are weak acids. The modified isoelectric point of the entire polymer were calculated as follows, with the A has an isoelectric point of 4.5, B 5.5, C 7.4, and D 9. And these particles are loaded with positively charged drug on the surface using electrostatic interaction in PBS at pH 7.4. So which of the following will have minimum loading? I'll give you some time to think on this question, and then you can let me know what you think the correct answer is.
Ma'am, what does it mean minimum loading?
lowest loading. So here you are trying to load these particles with uh, positively charged drug, right? So which of these will have lowest particle loaded onto the polymer? Or which of these will contain minimum amount of drug?
Ma'am, is it option D because it has higher isoelectric point than the mentioned pH?
Okay. Yes, we will actually discuss the answer. Let's first see what everyone thinks. Okay, so you are going for option D. What about others?
My answer will be the same, but my reason will be that the isoelectric point is almost closer to the basic level, which is if you add more positive charge, then more basic it will become. So the graph will reach little amount of positive.
Your voice is cutting off in the middle. I couldn't hear your answer properly. What about others? Anybody else has any other answer or same answer? Anybody? Okay, the correct answer would be D. Yes, the first logic was correct. So we have isoelectric point at which the charge will be neutral, and if the pH is more than the pH of the isoelectric point, then it will have a negative charge. But if the pH is less than the isoelectric point, it will have a positively charged. So here our pH is 7.4 and this is less than pH 9. So it will have a positive charge. Yes. So this will have a positively charged and we are also loading positively charged drug. So both of them will have a positive charge. So there will be some uh, repelling from both polymer and drug side. So you'll have minimum loading with pH 9. So the option will be correct answer will be option D. Here is the next question. Which one of the following polymers degrade hydrolytically by near zero order kinetics? Polylactides, polyesters, polyanhydrides, polyamino acids, polycarbonates, or polyamides?
Polyesters.
Okay.
Polyanhydride.
Polyanhydrides, okay. Anyone else?
Ma'am, option 3.
Polyanhydrides, okay.
Polyester.
Polyesters, okay.
Ma'am, polyanhydrides, ma'am.
Okay.
Ma'am, polyacetyl.
Polyacetyl. I don't think we have that option. Polyesters, you mean?
Option 1. Option
Polyactides.
1.
Polyactides. Okay. Okay. Anybody else? So the correct answer would be option 3, polyanhydrides. So it only the polyanhydride groups it produces near zero order release kinetics, that is constant rate of release due to surface degradation only, and all the others have even slower reaction, slower release rate because of the bond breaking. So susceptibility to the hydrolytic cleavage would be first anhydrides, then esters, and then amides. So here anhydrides will have near zero order release kinetics. Okay, let's look into the next question. Which of the following are correct with respect to PLGA particles? You have to select two correct options. It is a non-biodegradable polymer. It can be used as a vehicle in gene therapy. They can degrade at gastric pH. They have not been used clinically. It is not a copolymer, and they can be extracted from chitosan based products. Which of the following are correct with respect to PLGA particles?
Ma'am, option 2 and 3.
2 and 3, okay.
Ma'am, option 2 and 3.
Okay.
Same answer.
Okay. Anybody else? Which of the following are correct with respect to PLGA particles? Anyone else would like to answer?
Option 2 and 3.
Okay. Okay. So all of you are correct. Option 2 and 3 will be the correct answers. It can be used as a vehicle in gene therapy and they can degrade at gastric pH. So these PLJ particles, these are FDA approved as bioabsorbable sutures and has been used in drug and gene delivery and tissue engineering scaffolds. So it can be used as a vehicle in gene therapy, and the lactic and glycolic acids are the physiological products that are the byproducts after degradation of PLGA, and it gets metabolized by the body into carbon dioxide and water. So and it is catalyzed by acids and bases. So at gastric pH also it can be degraded. So option 2 and 3 will be the correct answer. Here's the next question. What are the advantages of using polyethylene glycol in drug delivery application? You have to select two correct options. Options are has well-developed conjugation chemistries, non-toxic, immunogenic, and can be produced under GMP, good manufacturing practice, highly hydrophobic and biocompatible, can be easily phagocytosed by immune cells, can deliver cargo intracellularly very efficiently. Which of the two options are correct for advantages of PEG?
Ma'am, it is option 2 and 3.
2 and 3, okay.
Option 1 and 2.
1 and 2, okay.
Ma'am, option 1 and 2.
1 and 2. Anyone else? Anyone else would
1
like
and
to
2, ma'am.
option?
1 and 2.
Okay.
Option 2 and 5.
2 and 5, okay. Anybody else? Yes, most of you are correct. And the correct answers are first and second option. It has well-developed conjugation chemistries. It is non-toxic, immunogenic, and can be produced under good manufacturing practices. If you go through the lectures in the slides, you'll find here that it is a very hydrophilic and highly biocompatible polymer. So, and it can be the backbone of the polymer is highly flexible. So both of these properties contribute to the molecular windshield wiper, which is why it is mostly used as to in conjugation to the particles or the drug to prevent adsorption of proteins and other molecules because it acts as a windshield wiper. So, and it is soluble in both aqueous and organic solvents, It has well-developed conjugation chemistries and non-toxic immunogenic and can be produced under good manufacturing practices. Also, it is FDA approved. Okay, this is the next question. If a particle takes...
Excuse me, ma'am.
Hello?
Excuse me, ma'am. Am I audible?
Yes.
So can you please show the previous question? I mean, what question that is shown just now? Because in the option, I remember it is immunogenic in the option.
Okay.
Second option is non-toxic immunogenic. If it is immunogenic, then it will be rejected by the immune system very easily right now. So it should be like non-immunogenic.
Right. But it's not completely non-immunogenic because I think very briefly it is also talked about that anti-PEG antibodies are also developed if you have gone through. So it is not non-immunogenic. That's why we cannot use it. It is very less immunogenic that you can say. I mean, it won't elicit a very strong reaction, but then it's
Yeah,
less
yes, ma'am.
non-immune. Yeah.
Okay. So in that option, non-toxic immunogenic, that will be the correct option, ma'am.
Yes.
Okay. Thank you.
Okay, here is the next question. If a particle takes time t to diffuse L mm, how long will it take to diffuse 4L mm? And these are the options. I'll give you some time to think on it and you can let me know what you think the correct answer is.
40.
Sorry? 4T. Option 2.
40. Yeah.
Okay.
Madam, 16T, 16, fourth option.
Okay. Anybody else?
16T.
Okay. Anyone else? If a particle takes time t to diffuse L mm, how long will it take to diffuse 4L?
16T.
Okay. Okay, most of you are correct. It will be 16T. So here the diffusion of the particle diffusion distance x is equals to under root 2 dt. So if we follow this equation, we have it will be x square equals to 2 dt. So initially it's L and capital T, and when it is 4L, if you take small t as the time you want to calculate, then it will be 16t. So the fourth option or 16t will be the correct answer. Here is the next question. Reservoir system refers to, the options are, a system saturated with drug surrounded by degradable membrane, all systems with zero order release rate, all systems with first order release rate, systems which have non-degradable membrane and are supersaturated with drug, all systems with second order release rate, systems with a semi-permeable membrane which degrades with time.
Option 4.
Okay. Anybody else?
Option 4.
Okay.
Option 6, ma'am.
Okay.
Ma'am, option D.
Option B. Okay.
Ma'am, D, 4.
Okay. Okay. Anybody else would like to answer which of these is the reservoir system? Okay, most of you are correct. It's option D. Systems which have non-degradable membrane and are supersaturated with drug. So this is the basic definition: a supersaturated drug reservoir which is surrounded by a non-degradable polymer membrane, and it could have a planar configuration, and it could have a cylindrical configuration, and most commonly used polymers are silicone elastomers, and it can achieve nearly constant or zero order release rates. So fourth option, which is systems which have non-degradable membrane and are supersaturated drug, will be the correct answer. Okay, this was all the question I had for this week, and probably by next week you'll all would have submitted your assignment. So if you have any doubt in the current assignment, also we can discuss by next week. If anybody else has any doubt or wants me to repeat from the start, you can let me know.
Ma'am,
Yes.
I have a doubt in this question.
Yes.
Reservoir system means that we have a controlled release of drug over time,
Yes.
right? So
It's
if we have like a
yeah.
non-degradable membrane, how is that supporting that definition?
It's like it's diffusion basically. It's not degradable. It's mostly dependent on the diffusion of the drug. The membrane is not degradable. This membrane is not degradable, but it is permeable to the drug. So since outer side would have a low concentration of the drug, there will be diffusion from here to here at a constant rate. So you are constantly
Okay,
delivering the drug. Yes.
but over time it will stop now.
Over time it will get over. I mean, after diffusion, it's as I said, it's diffusion. So since it is a super saturated, it's very high concentration inside. It will continue till the point the outer part is not equal to the inner system. And it's like if you have delivered this inside body, then even if there is drug here, it is still getting transported to somewhere else. It's not like it's getting saturated here, right? So it will always have
Hmm,
a higher concentration inside, so there will be constant diffusion, which is why it has zero order release rate.
okay.
Ma'am, I have a doubt in the third week assignment based
Third
on the
week assignment.
question
Okay.
yeah, about the thickness of the membrane. Uh, I am not sure how to calculate that.
Okay, actually we can't discuss the current assignment that you are going to submit. If you want to understand the concept or something, we can discuss, but only after you have submitted the assignment we can discuss those things. Besides, I think next week we'll discuss the third week topics and some previous year questions. Maybe that can help you more in solving the third week assignment.
Okay, ma'am.
What is the last day to submit third week assignment?
It's 14.
14. Okay.
Ma'am, but I was not able to find that in the lectures.
Okay. I don't know the question at this point. Uh, I'll check and maybe next week we can discuss. You will still have time, I guess. Yeah, one day before. Can you let me know what the question was?
The question is a numerical type, and they have asked us to find the thickness of the permeable membrane, and the details that they've provided is the thickness of the reservoir system and the amount of drug released in a particular time t.
Okay.
And they gave that there is a desired amount of drug that has to be released
Mm-hmm.
from the overall content. So, how much should the thickness of the membrane be so as to release that much particular amount of drug?
Okay.
And it has to be reported in micrometer.
Okay. Uh, I think for reservoir systems there is equation if you go through the lectures. If you use that equation, maybe you can solve. Did you not find any equation for that?
There were a good number of equations, but I did not find a direct relation between the thickness, time, and the amount of drug with respect to the thickness. But
I
I
think
will
I think there
check
is the
again.
equation. If you go through carefully, I mean, look at the equation and just refer there what all each term means. Then you'll find there is one equation where both thickness and time and all these things are involved. If not, maybe you can make a correlation between thickness and time. If you're not getting the direct equation, if it is giving some correlation also, I think you can make out something of it.
Okay, ma'am, I'll check again.
I can't discuss that question since the deadline is not over, so I can't help much. But maybe next time I'll try to look into that question again and see if I have any other similar question to that I can explain here.
I have question from week 2 assignment.
Okay.
It was about VD effect of distribution of drug in half life of drug.
And half-life of drug. Yes, okay.
So I was not able to because there was like a calculation part.
Hmm.
So I was not able to understand how VD is affecting half life of drug.
You have to look at the entire question to answer this, and you have to see what you need for solving or getting the half-life of the reaction. It doesn't matter whether VD is given or not. For calculating the half-life, do you have all the information there or not? Just look into that. Maybe that will help.
Okay.
Anybody else has any other questions or doubts?
Ma'am,
Yes.
ma'am, can you explain about second order reaction and its equations?
Second order. Okay.
Yes, ma'am.
I think there is a proper lecture on it on second order reaction. It's basically so your second order reaction would be basically dependent on two different reactions. I'm not sure what do you want me to explain here. The rate of reaction here depends on two different components.
Ma'am, sorry to interrupt, but if you have no other doubts, can we leave?
Yes, yes, you are ready to leave.
Thank you.
Are you asking this because of the assignment questions where it is asking for a second order reaction?
Yes, ma'am.
Okay. Try to look more into the options. You'll find the answer there itself. But the second order reaction is basically this only, that you have a both two components, basically A which have a power, some power x, and B some power y, and a constant. You have to solve it accordingly. Just try to put which all equations you can put in this form, and all those equations are correct for second order reaction.
Okay, thank you, ma'am.
Anybody else has any other doubt? If not, we can close this session here. If anyone has any other doubt or wants me to repeat from the start again, can let me know. Do you people have any doubts? Okay, we'll close the session here. See you all next week on week 3 TA session. Thank you for joining.